This is the first part of the lesson video for 1-7 on functions. You can pause this video to catch up on notes. You could pause the video to ask a question. Okay, please don't race through the video. You need to listen to it so that you have all these ideas. In 1-7, we're going to start talking about the difference between two different groups of relations. And relations we looked at yesterday being anytime we have two quantities related to each other. So relations today are going to be broken down into two groups. Groups that fall into a category we call functions, so relations that happen in a certain way, and then groups that don't meet that standard and are separated into ones that are not functions. And we want to be able to tell from all those different ways that you had mapped out your relations yesterday. So we want to be able to tell from graphs, from tables, from mappings, and from lists of ordered pairs. So to get the idea of a function, let's go to something we understand pretty well, and most of you understand the cell phone stuff pretty well. So stored in contacts, you have a contact, or this person does, for someone named Kate Bell. She's a producer. She has several phone numbers listed because she has a cell phone number, a work number. So on your phone, when you go to the dial screen and you either ask it to find her contact or you actually type the digits in, either way, for an input of, so our inputs are going to be here, just like your mappings from your section before that. And then outputs, what happens when we input a certain number into your cell phone, what the result is, what that dependent variable is. And on your cell phone, who you reach on the phone depends on who you input as your contact or what number you dial. So if we dial this first number, the 555 area code number, you can't see it very clearly, but that is her mobile number. So if that's the input to your phone, our expected output is that we reach her. We actually reach Kate Bell on her phone, or her voicemail, but we reach her phone. The second number that you would input into yours, think of X values as input, second value you're inputting is this next number, and if you can look really carefully, this next number is listed as her mobile number, or her main number. So our expected output is that our phone is going to reach Kate Bell. A day or two later, we dial that 555 number again, and the expectation is that we'll reach Kate Bell. If we went and dialed that exact number again, and we reached someone else, let's say that we reached Ms. Berg, and we didn't misdial, and she didn't change phones, so Kate Bell's phone numbers are still Kate Bell's phone numbers, we would say that something's wrong. We would say that our phone is not functioning correctly. The reason we would say that is that input, even if I use it over and over and over again, we'd expect the same result. We'd expect if our phone is a functioning machine, that when we dial that number, we would reach Kate B each time. If the one time I enter it, I reach someone else, I have an output that's different, then we would say that this is not functioning because one input has given me a different output. So we're just going to put up here for a minute that this relation is not a function, so we can come back to this idea of the phones. We'd also get the idea that something's wrong with our phone. It's not just in the real terms of functioning correctly. So in algebra, to be defined as a function, it has to first be a relationship between two variables. So a function is a relation. We looked at relations yesterday, just talking about two quantities related to each other, an independent and a dependent variable, in which each element, that's each part, each number of the domain, and you think, ooh, element of the domain, you lost me right there. So think about it as each input is another word you can say, each X value. Each value of my independent variable is paired with, to be this functioning relationship, exactly one element of the range. So exactly one's important. Element of the range just means one output or one Y value. So to actually be this idea of a function, we're going to read it one more time. A function is one of the relations where each input has exactly one output. So I'm going to go back up to our phone example. The first time we input this number, we reached Kate Bell, we had an input, and there was our output. We tried that input again, and it gave us our output again. So far it's functioning, this relationship. We tried that number again though, and now I have a different output. So the input of this number had two different outputs. So we would say this is not data that's considered a function. So let's look on another mapping and see if we can find out what would make it this. So not in context, meaning we don't know the meaning of these domain numbers, these input numbers. So into an equation, into anything, we input a -3, it outputs a 5. So -3 has an output. -3 never has a different output anywhere else. 0 only has one output, 2 only has 1, and 4 only has 1. So if I look at that definition, it says it has to be a relation between two quantities, and each element of my domain, -3, 0, 2, and 4, is paired with exactly 1, so this one is a function. It meets that description. We're going to come back to the graph, but that graph is a function. In the second video, we're going to come back to what to do to tell if graphs are, but first we're just going to focus on those input-output tables, those mappings, and data tables to tell. So on these 4 examples for each one, we need to decide if it is a function, why not, or if it is, why, and if it isn't, why not, from this mapping or from the data tables. So you could try one, come back and turn the video back on. You can just stay with us and take them as notes, but by the time we've done 2 or 3, see if you can guess ahead of time and maybe pause the video. So in this first example, number 1, they've got the domain values listed in your mapping, they have the range values. In those values, I only see for each x, or for each input, I only see one value output. So this data seems to meet that definition for function because of that. So this one is a function. And we want you to be able to give reasons why. So each input has exactly one output. So take a minute to get that neatly, even pause the video. The next mapping. I'm going to look at this next mapping. So -1 is my first input. And the first time I use it, -1 outputs a 4. Then I input -1 again, think of my cell phone. And this time I get a 5. So this one is not representing a relation that's a function, because I have one input that has multiple outputs. And I have that again in some other places, but one input, all it takes is one. One input, that's that -1, has more than one output. Again, pause the video so that this goes in neatly and you have each of these reasons in your notes to come back to. The next table. On the next table, they've got domain values of -7, and if you want to think of a mapping, add those arrows to help you. Okay, -4, 2, and 5, so each input is fine. Each input has only one output, so this relation, whatever this data represents, is considered data that fits the function description. And again, we're trying to use repetition to drill this idea, at each input has exactly one output. That's a definition of what it takes to be a function. And on the last data table that we're looking at, I see an input of 3, it outputs 2. I want to look down that table for repeated inputs to see if my phone's functioning correctly, the relation. This one has a repeated input and a different output, so this one is not a function. It's just like the cell phone example. One input has more than one output. So the conclusion, we want this to be kind of the rule, the thing we might consider putting on our note card as our test or our way of telling. A relation is a function if each, and we can put several things in here, x or input value has only one y or output value. Write it neatly, process that through, stop the video when it ends, and then go to the next one.